Alright, today we're going to look at solving radical and rational exponent equations. Remember that our radicals are also written as rational exponents or vice versa. So if I have x to the 1/2, the number that is in the bottom goes in the crack of the radical, and the number that is the numerator is the power that it is being raised to. When we solve radical equations, the first thing we want to do is get that square root by itself on one side of the equal sign. Once it is by itself, we can square both sides to undo that square root. So remember, this goes back to when we were trying to solve for inverses. How do you undo something? Then the last thing we want to do is solve and check for any extraneous solutions. So sometimes when we square both of those sides, we create an answer that isn't actually an answer. So we have to check those once we are done. Alright, so let's look at this first one. I have 3 times the square root of x minus 2 minus 1 equals 11. So I want to get the square root by itself. So the first thing I'm going to do is add this 1 to the other side. Then I'm going to get 3 times the square root of x minus 2. Okay, so picking back up since we got interrupted by the announcement, I added the 1 over there, so I'm going to get a 12. My square root still is not by itself because I have this 3 out front, so I'm going to go ahead and divide both sides by 3. On the left-hand side, I'll be left with just the square root of x minus 2, and 12 divided by 3 gives me 4. Now my square root is by itself on one side of the equal sign. To get rid of this square root, I square both sides. When I square a square root, it goes away and I'm just left with the x minus 2. 4 squared gives me 16. From here, get the x by itself. I'm going to add 2. So I get x equals 18. Now, we're not sure if we created an extraneous answer, so we still need to check this. So I'm going to come back up to the original, and I'm going to substitute 18 in for x and see if I get a true statement. So is 3 times the square root of 18 minus 2 minus 1 equal to 11? So 18 minus 2 gives me 16. The square root of 16 is 4. So 3 times 4 gives me 12. So I get 11. So is 11 equal to 11? Yes. So this is a valid solution. All right. Let's go ahead and look at a couple more on the inside. So right here, I have the square root of 2x plus 5, and then plus 8 equals 5. So the first thing I'm going to do is I'm going to go ahead and subtract this 8. And I'm going to get the square root of 2x plus 5 equals a negative 3. Now, we know that when we take the square root of a number, it cannot be negative. So can the square root of 2x plus 5 equal negative 3? No. So this one is going to be no solution. Because if you went all the way through this and ended up solving it, when you checked your answer, it shouldn't work. So you have a safeguard when you check that answer, because when you come over here, it's not going to work. All right? Right here, I have the cube root of 4n minus 8 minus 4 equals 0. So I'm going to go ahead and add the 4. So I end up with the cube root of 4n minus 8 equals 4. Now, how do I get rid of a cube root? Well, I cube both sides. So when I cube a cube root, it goes away. And when I cube 4, I get 64. So on this left-hand side, I'm going to get 4n minus 8. And I'm going to get 64 over here. Now I need to go ahead and solve for my variable. So I'm going to add 8. So 4n equals 72. Divide by 4. So n is equal to 18. Again, take that answer and take it back up. Is 4 times 18 minus 8 minus 4 equals 0. Well, we know that 4 times 18 is 72. So then 72 minus 8 is going to give me 64. Well, the cube root of 64 is 4, so is 4 minus 4 equal to 0? Yes. So sorry, you couldn't see that. So as I work it out, sorry, I'll leave that on there for just a second. So as I work this out, I get 4 minus 4 equals 0, so 18 is a valid solution. Right here, I have a square root on both sides. I'm not going to move anything around. I'm actually just going to square both sides from here, because when I do that, it'll get rid of both square roots. So on the left-hand side, I'm going to get 5x minus 7. And on the right-hand side, I'm going to get x plus 13. Now, I need to solve for my variable. So I'm going to go ahead and move the x to the left-hand side. So 4x minus 7 equals 13. Then I'm going to add my 7. So I get 4x equals 20. Divide by 4. And I'm going to get x equals 5. Again, I want to check to make sure that this works. So 5 times 5 minus 7, is that equal to 5 plus 13? So on the left-hand side, I'm going to get 5 times 5, which is 25, minus 7. Over here, I get 18. 25 minus 7 is 18. So is the square root of 18 equal to the square root of 18? Yes, so x equals 5 is a valid solution. All right, now let's look at how we solve rational exponent equations. They are similar because we are going to have to get the variable that's being raised to the rational power by itself. Then we raise each side to the reciprocal exponent. So this one's being raised to the 2/3. So the reciprocal would be raising it to the 3/2. Then solve and check for any of your solutions, any of your extra solutions. Just like with the other equations, I need this term right here, which is the radical term. We're just not writing it as a radical. I need that to be by itself on one side. So I'm going to have to divide by 3 first to get that x to the 2/3 by itself. 48 divided by 3 gives me 16. In the past, on these over here, to get rid of the radical, we squared it, or we cubed it. Over here, since this is raising it to a power, I'm going to raise it to the reciprocal power, so 3/2. I do that because my exponent rules say that a power to a power, I multiply. So I'm going to get 2 times 3, which gives me 6, and 3 times 2, which gives me 6. So I really get x to the 1. On this side, I'm raising the 16 to the 3/2. Here is where we want to go ahead and use our properties from last class, where we can rewrite a rational exponent as a radical. Bottom goes in the crack, and then I'm still cubing that. So what is the square root of 16? 4. And then I'm still going to cube that, so I get x equals 64. Okay? All right, right here, let me move that up so you can actually see it. Again, right here, I still want to get this whole term by itself. So the first thing I'm going to do is add 1. So then I'm left with x plus 2 to the 1/3 equals 2. We're raising this x plus 2 to the 1/3, so I want to raise it to the reciprocal, which is 3/1. I've got to do both sides. On the left-hand side, remember, power to a power, it's just going to give me that 1, so I'm going to end up with just x plus 2. This is essentially squaring a square root, cubing a cube root. That's what we're doing when we're raising that to that power. 2 cubed is 8. Then I still need to get that x by itself, so I get 6. All right. Right here, we are saying 1/7 times 7a raised to the 1/3. I need to get this 7a to the 1/3 by itself. So first thing I'm going to do is multiply by this 7 over 1 to get rid of that fraction in the front. So I'm going to end up with 7a to the 1/3 equals 7. My base is by itself, so I'm going to raise to the reciprocal. So I'm going to cube. So on the left-hand side, again, my 1/3 to the 3rd, that's like cubing a cube root. So I'm just going to get 7a by itself. So I get 7a. Over here, 7 cubed is 343. But then I'm going to divide by 7. And it should give me 49. Okay. So solving radical equations, we isolate the square root and then we square it, or we isolate the cube root and we cube it. On solving rational exponent equations, it's the same idea. We're going to get that base raised to that power by itself, which is essentially getting the radical by itself, because we know that rational exponents are really radicals. All right, there you go.